Hello, this is Mark again. This will be part 11 of Power Supply Current Saver. Proof it's feasible. I have to do one more part because the last part, part 10, it didn't show the current. The screen was too dark. So I have to just do it again. But after I show that, I'll be talking about these two books. This one was copyrighted in 1971 and this one in 1984. I'll show you those after. Now here's the circuit again that I showed in part 10. So I'll turn it on now and we'll test the current again and make sure you can see the display when I'm down here measuring this wire. There, the bulb is on. So the current going through these capacitors and the bulb is about, there it is, 0.21. Yeah, that's what I measured yesterday. Now down here, yes, it's 0.05 or 0.06. So that's really close to 72%. Not quite. That's how much electricity, how much current it saves. So I hope you can see that this time. The current doesn't actually go through the capacitors. It's used to charge them up because there's a dielectric insulator in between them. So the current doesn't go through it, but it appears to pass AC, electricity. They block DC electricity, but AC, they appear to pass it because it charges one side and then the other side. Okay, now to these books. Now this one, on page 104, there it is. It talks about voltage multipliers. Voltage doublers it talks about first. Now these are half-wave voltage doublers. And down the bottom here is the full wave. Voltage doubler. There we are. I'll just grab my pen here. Now here's where you take the output to run some devices. But for example, with the 120 volts is coming out of the transformer, you'd have 240 volts here, but it's not much use unless you want to run a 240 volt heater, if you could wire it up properly. So they don't know any other way to do this except put two 120 volt devices in series connected to these leads at the top here, one there and one there. And that's very inconvenient because you have to have the device on the same settings, and if someone turned one setting down, the higher one could damage the lower one. And this is what I display here in diagram 3 to use that. So it's inconvenient. But you can always do this, diagram 8. run two transformers, this one and this one in series, and then you can run one device, or you can add more devices on in parallel to R1 up to the limit of the transformers. Now this is what this circuit here with the capacitors, the variable capacitor I should say, I'm going to use later, and the device connected in series will solve the problem with these. And tonight I'm going to work on making a schematic diagram of my own to explain it better. Now on the other page, it shows voltage triplers. Voltage tripler, that would go to 360 volts, and a voltage quadrupler, which go to 480 volts. And each time you add more, multiply more, it saves more current. So if you went to 600 volts, I'm sure you'd save 80% using the transformer method like this. But using this method with capacitors, it's going to save even more, which would be astounding. Okay, that's in this book here. So I have to go to okay, just hold on here for a minute. Find the page. There it is. This is a voltage doubler also. Looks like it's just a little slightly different method of doing it. But that could be applied to something too. One method of doubling a source voltage using rectifiers and capacitors. Okay, now something I want else to say about these diagrams. This will be a very effective circuit once you get those capacitors involved, or variable capacitor. And then of course at the load device you'd have to have a voltmeter attached to it so you can adjust the capacitor to the voltage you want. Something else I want to say about this, and now I can't recall what that was. I'll be experimenting with this more, this diagram. Try to get it to work. So my next step is to clear this table and set it up for 240 volts. And I'll probably do that today, since I'm feeling good. Okay, thanks so much for watching. I'll see you on the next video.